We're circling back around now to 7.4, what we're going to call the leftovers of this section. At the beginning of 7.4, which we did earlier, we looked at factoring special forms if they were two terms. The rest of 7.4 deals with a special form that is a trinomial, which means that everything you're about to see, you don't really have to utilize this. This is a time saver should you choose to memorize this next pattern. It's one more special form to memorize that has to do with trinomials, three terms. But what we did earlier in 7.2 and 7.3, the splitting of three terms to four terms so that we could factor by grouping, also works with these problems. So what I'm about to show you is an option for those of you that maybe want to look for some time savers on the test and you're ready to get one more form to memorize. But let's review just a little bit here. When we are factoring, what we're really doing is we're undoing, or we're splitting apart, the results that came from multiplication or distribution or foiling. So factoring is really the splitting or the undoing of that, going back to the original setup before it had been foiled or distributed or multiplied together. And we're going to get boringly good at factoring by always doing two things before we get started. One is to check for the GCF, always. We are going to always check for this first. This requires a little training because there's several chunks in the assignment where you're focused on the actual factoring and they don't throw in ones very often that have GCF. So you always want to train yourself to always ask for this first, even if you know that you aren't going to see it for a while. And we did this in 7.1a. The next thing that we're going to do after we always remember to check for the GCF first is we ask ourselves how many terms are we looking at. That will determine our next set of steps, okay? Each one requires something different. So if it's two terms, and we covered this in that first part of 7.4, we called it 7.4 most because it covered most of that section. It is one of the special formulas that we are memorizing how to factor in the case of difference of squares, difference of cubes, or sum of cubes. We've been abbreviating that DOS, DOC, and SOC. Difference of squares, difference of cubes, sum of cubes. And it begs the question, is there a formula for sum of squares, like x squared plus 9? And there's not. There is no formula for sum of squares. If you come across that situation, you do not have to factor any further. It's prime at that point. GCF first, then how many terms. If it's two terms and it matches one of these situations, it's a difference of squares, two squares being subtracted, difference of cubes, two perfect cubes being subtracted, sum of cubes, two perfect cubes being added, then you rely on one of those special forms. Then we moved on to the second part of 7.1, and we called it 7.1b, and that was if you were dealing with four terms. And our method for factoring four terms was to factor by grouping. You look at the first two, what do they have in common? Look at the second two, what do they have in common? You pull out those GCFs of those sets of two, then you'd expect them to show a big, we called it big in quotes, GCF that you could pull out. So that was what we did in factor by grouping. And factor by grouping, once you get the hang of it, it goes pretty smoothly, pretty easily. So one of the things that we emphasized when learning how to do three terms, and this is what we did in 7.2 and 7.3, was to then convert those three terms back to four terms. So we take the three terms, turn it into four terms, that way we could use factoring by grouping, because for a lot of people that really is good. It's an easy method to follow. And the goal of going from three terms to four terms is to perform a strategic split. Strategic meaning we just don't randomly pick two numbers to split it into, but we take that B term, so it's a strategic split of the B term, actually back into its original outside, outside, and inside, inside pieces that would have been multiplied. So it was, you know, it starts as the OI where those two terms have been combined, those two like terms that happen when you FOIL, and then we're going to split it back into its original O pieces and I pieces when you multiply the outside, outside, and inside, inside together. And so there were steps to do that. You'll find those in the notes for 7.2 and 7.3. So again, what we're looking at here is just another special situation. So that's what's still in the section on special forms, but it does involve 3 terms. So let's recall what the standard form of a trinomial is. This is 3 terms is what we're looking at. It's when you have ax squared plus bx plus c. Okay. Now, what we're going to look at is a special version of this. Once again, you don't have to learn this special version because what we did in 7.2 and 7.3 will work on any 3-term trinomial. Okay, it will work to factor this form. This is just a special version that if you want to learn it, recognize it, it will go much faster for you. It will save you lots of minutes. So totally up to you if you want to utilize this or not. Here's what it would look like if you have, okay, big if. You have an ax squared plus bx plus c situation where the a, the coefficient in front of the x squared, is a perfect square, like 9, 1, 64, 121. Those are all perfect square numbers. There's something times itself equals, like 3 times 3 is 9. 11 times 11 is 121. Those are examples of perfect squares. And your c value, your constant that's out here at the end, is also a perfect square. And the third condition, because the first 2 conditions are fairly easy to check for, this third condition is a little bit different, but you'll get the hang of it once you decide to start trying this one. If you take it's going to be double the square root of a and the square root of c. So in other words, whatever's making this a perfect square, if it were 9, we'd be looking at 3. The square root of 9 is 3. If this were 25, we'd be looking at 5. And you'd multiply those together. Square root of 9 is 3, square root of 25 is 5, 3 and 5 make 15. And if you double it, and that matches this, 15 doubled would be 30, then you've got the situation where you can factor it, and it would look like this. You would put your square root of a, square root of c, square root of a, square root of c, and your sign will match the original sign of the b term. So in this case it's a plus, so we'd put a plus here. If you had ax squared minus bx plus c, then these would be minus and minus. Let's do a couple examples here, and then you can decide if you would like to complete this assignment using this special form. It's called a perfect square trinomial. You can see the name is just what it is. You've got perfect squares here on the front and the end, and then the middle is the double of the square roots of those, the product of the square roots of those. So you're going to be practicing factoring those. Again, splitting the 3 into 4 terms and factoring by grouping will also work with this. The nice part about doing it with the perfect square trinomials is you save time because the numbers get pretty big on some of these when you're trying to convert 3 to 4. But it is doable. So you and the calculator, you can kind of get into a rhythm. It won't take you that much longer. So you really have a choice here which method you end up using for the exam. Okay. Let's look at this first one. Actually, I'll pause the video and we'll move down the page. Or I'll stop the video.